Welcome back to Kicked Up. Going to be a laboratory experiment. We're actually in a real chemistry laboratory this time. So this is our gas chromatograph, and we will be using the GC here in order to separate a mixture of 5 different compounds. And those 5 compounds are methanol, ethanol, methyl ethyl ketone, ethyl acetate, and butyl acetate. And I'll cut away here in just a couple of minutes and show you the little more in detail of how the gas chromatograph actually works. But basically, if we take a tour of it here, this is our Vernier Mini GC. Here is our injection port in which I'm going to be injecting our mixture of the 5 different liquids, which are then going to vaporize. As it goes through there, it's going to stick through the tubing. So inside here, there's a big coil of tubing with an adsorbent material, just like a thin layer chromatography type material. And it's going to allow those different solvents to come through at different times, which is then going to hit a microchip. And we'll measure that as a voltage spike. So this one just uses regular air. So there's an air intake port and an exhaust port here on the back, right there. And then it is going to display it up here on the computer screen. And so the first thing we have to do is set all of the different parameters. And so if I go up here to experiment, we'll just hit cancel here. And there it pops up. And again, if you do not have this laboratory sheet and you are not in my class where you can actually get it easily, you can just send me an email. And I will be more than happy to send you a copy of this, either as a PDF or as a Word document. And we're going to identify it. So the first thing we're going to do is I'm going to run this one through here, and we're going to identify that one and see if we can't do that one together to try to figure out what that one is. And then I'm going to give you a set of unknowns that's going to have somewhere between 1, well, it would be pretty boring if it's 1 and 4 unknowns. So I'm not going to give you all 5. On the front side of that sheet, the biggest thing is the time that it comes out. So if I focus that a little bit more, and I've got all of these, and again, in a minute I'll cut away and insert that video of showing this in more detail, but you can see how these peaks come out. This one has a little jagged area there where the methyl ethyl ketone was on its way out when the ethyl acetate started coming out then as well. So this one was about finished as that one was there, so it kind of overlapped. By changing these different parameters then, our starting temp, ending temp, the ramp rate, which is how fast it heats up, the hold time, which is the retention time, we can tailor this to separate the solvents the best that we can and then identify them. And then again, the biggest thing is looking at what time did it start coming out. The shape of the graph tells you a little bit, but it's more the time than anything else. Here is the syringe that I will be injecting it with. This is a 1 microliter syringe, so that would be 0.0000001, if I did enough zeros there, liters. And we're not even using an entire liter, we're only using 0.8 microliters. And so it's a very, very small amount. And it has a little stopper on here because if I don't have the stopper on there and this pulls out, this goes all the way down through here. It's so small that it's almost impossible to get the metal piston back into the actual needle portion of it. So since we are in a laboratory, and I will be injecting, first of all, the unknown material, just the one of them, so we can get this peak here, I will be putting on my laboratory goggles. And so let me click on here. And well, through the magic of editing, I'll wait for this to go down to the 35 degrees Celsius starting temperature. Okay, while we are waiting for the GC to cool back down so I can inject it into it, it's a good point to take a look at exactly how the GC works. So again, gas chromatography is a technique widely used to separate complex mixtures of substances. Compounds are separated by traveling through a coated column and typically separate based on the size and intermolecular actions. So again, you can read through this. If you do not have access to this, send me an email. I'll be more than happy to email it to you as a file. Here is the same GC that chromatogram that I did that has all 5 of them on there. This is on the other sheet as well, your lab report sheet. And then here we have a diagram of the GC. So ours uses regular air. Other fancier ones will use a carrier gas, a lot of times nitrogen, which is very inert, a gas flow regulator, in order to get the airflow through here. It heats it up, so it's in an oven, and this is that coil of tubing with that adsorbent material on there. There's the injection port. So when I took that syringe, injected it into here, went into this hot stream of air. In our case, it was air, which is 78% nitrogen anyway, instead of being pure nitrogen. And it travels through the column, and because of the different sizes and the different ways that it sticks to the inside of the tubing, it came out at different times, hitting the detector, which then picked it up on the computer as a voltage signal, and that's how we got those spikes. And the noise that you heard coming out the back was the vent, where it just vented it out into the air. Now we could have taken that and hooked it up to a mass spectrometer, and that's a very common device called a GCMS, Gas Chromatograph Mass Spectrometer. So it immediately injects it into there. It allows you to analyze the compound using mass spectrometry, so you can pretty much tell exactly what that compound was if it was an unknown. And again, the retention time is the biggest key here. All of these were done at the exact same parameters, starting at 35 degrees Celsius, 5 degrees Celsius per minute ramp rate. The retention time or the hold time were all the same. So you're really looking at the times at which these came out. So this is a diagram of the inside of the GC tubing. So we can see a few silica substrate. There's the stationary phase, and then the coating just around the outside of it. This is the Vernier GC that we have been doing. And so we'll continue now with the injection of the compound, our first compound, which is the single one, into the GC and see if we can't analyze that one and see which one it is. Okay, so now that the GC is down to its proper temperature, the hardest part is injecting and clicking at the same time. So I'm going to inject that in there, so I get it all ready to go. I'm going to hit collect and inject it in. And now we should start seeing the graph as it's going through. We can see over on the left side over here, it's giving us the raw data with all the numbers, and then it's graphing it out for us as well here. And so as this proceeds then, we will get the value for this unknown right here. So we should get a graph that's going to look pretty darn close to that one. If it wasn't reproducible, then obviously it's not a really great scientific piece of equipment if it's not a repeatable measurement. And so as it's going along, we can see the little line right here. That's at 1 minute. There's at 2 minutes. And what we're going to be looking for is something to come out at a little bit past 2 minutes or so on there. I would see a couple little peaks. And now we can see that indeed, a little after 2 minutes here, about 2 minutes and probably 15 seconds, we definitely have our peak being shot straight up.
And if we compare that to the one that we're looking for, again, it'll rescale it once it's actually complete. It's going up here because this one's actually at about 1700 for a peak. I'll just set that right there. And again, this is a signature indicative of one of the questions on the lab, so I obviously can't tell you exactly which of those compounds, which of those 5 compounds I put in there. And we can see that at about 4 minutes, it should be pretty much complete. So we're at about 3.5, and bam, there we go. It drops off like a rock. Now, I do have to make sure that it evacuates the column completely. Otherwise, there would be a contaminant in there, and we obviously don't want contamination in there when we inject our unknown into it. Okay, now that the GC has cooled back down and it's reset, we are ready for our unknown. And again, once this is done, I will print this off and upload it. And so that way you will be able to analyze then the peaks and identify the unknown. So again, I'm going to click collect, inject it in, and this will take a full 10 minutes to run completely. So in between peaks, I will speed up the speed of it a little bit, and so that way it doesn't take quite so long through the magic of editing. You can see that it is going through the column. Nothing coming out quite yet. So we're approaching 1 minute. There's just past the 1 minute mark. And there we have our first peak at right about 1 minute. Column before the signal is dropping back down. At 2.5 minutes, and it appears that we have a second. And there it is cleared the column as well, dropped down. And there are 3 unknowns that I ran through here, so we will, through the magic of editing, speed it up until we get to that 3rd unknown. Okay, just in time there. Our experiment ran out of time, and I'll let this run for just a couple of minutes so that way it clears it out of the column so it's ready to go for next time. But we can see that we indeed have 3 different peaks here. We can actually go through and analyze it and write down exactly these times they are. Because again, it is the time that it starts coming out where it really is how you identify what the different unknowns are. And by cursoring over onto the graph, I can see the points, and right here it'll give me the time and then the signal. Now we don't really care about the signal, so that's 1.463 minutes. So 0.463 times 60, that gives us 27.78 So let's call it 1 minute, 28 seconds for peak 1. So I'll put that one right there. And then if I cursor over to peak 2, it starts coming out right about there, which is about a little more, right about there, about 2.446. So we'll call that 2 minutes and 27 seconds. And then our third peak, we'll put it right where it's starting to come up there. That's right at about 7 minutes. Go back a little, 30 seconds probably. Right around 7.5. So 7 minutes, 30 seconds. Okay, again, here is that run then that we just did, and right here, that first peak is at about 1 minute and 28 seconds, like I said in the video. The second peak is starting here at about 2 minutes and 27 seconds, and then the third peak starts about here at 7 minutes and 30 seconds. So what you want to do is compare these peaks with the introduction to the GC sheet that I went over earlier and that you can download that has all 5 peaks on there, and then identify these 3 peaks and record that onto your report sheet to submit. And so now, using this sheet where you were given the different times on there, comparing them to these times, you identify the 3 unknowns that were in our compound. And again, your choices are methanol, acetone, methyl ethyl ketone, ethyl acetate, and butyl acetate. And don't forget to answer this one as well. Identify this one as well. Okay, so that is the gas chromatography lab. I apologize that the audio was kind of cutting in and out. The microphone wasn't picking up everything really all that great sometimes. But thank you again for watching Kicked Up Chemistry. Complete your laboratory experiment then. Introduction to the gas chromatograph. Thanks for watching.